So now we're going to do problem 35 from section 15 homework. We have a function f of xy, which is given to us. We have a region that we're restricting our x and y. It's inside this region where x squared plus 4y squared is less than or equal to 16. You might remember that x squared plus 4y squared equals 16 is an ellipse. We're not going to need to know that it's an ellipse for this problem, but it might not hurt to know that. And we want to determine all the points x and y inside this ellipse for which the absolute max and absolute minimum occur, as well as what the absolute max and minimum values are. So first we're going to look inside the ellipse, and to find out what points we need to look at inside the ellipse, we're going to take the partial derivative of f with respect to x and the partial derivative of f with respect to y and set them equal to 0. So when f sub x, when we take the that derivative, we're going to get 4y squared from here and a minus 4 from here, and I factored that. So taking out the 4, we have y squared minus 1, so that's y minus 1 times y plus 1. For the derivative of f with respect to y, I'm just going to have an 8xy coming from this, and this will be 0, and so we just have an 8xy. Now, both of these, it's easy to see what the roots are, where they're 0, and I'm just going to use this one. It doesn't make any difference which one you use, and I'm going to consider the possibility that x equals 0 and the possibility that y equals 0. So when x equals 0, I need this to be 0 as well, and so I need y to be 1 or minus 1. And notice when y equals 0, I'm going to need this to be 0 as well, and so y will have to be plus or minus 1, but that's not possible. It's not possible for y to be 0 and plus or minus 1. So really the only points we need to consider is when x is 0 and y is plus or minus 1. So inside the region, we just get these 2 points, 0, 1, and 0, minus 1, when x is 0 and y is plus or minus 1. Let me go ahead and take these 2 points and plug them into f right now. You can see x is 0 on both of those points, so this will just be 0, and so the value of the function at those points is 0. Now we want to look on the boundary. Now on the boundary, we're going to have x squared plus y squared, plus 4y squared equals 16, and so we want to use the extra 4 here in the y squared, so this part, to say that 4y squared is 16 minus x squared. And so f on the boundary is going to be x times the 16 minus x squared, and then minus the 4x. So points on the boundary we're going to get by looking at the function g of x, which again is the value of f on the boundary. And again, this 16 minus x squared here is coming from the fact that when I solve for 4y squared up here with an equal sign here, this is going to be 16 minus x squared. So the 4y squared I'm replacing with 16 minus x squared. So we have x times 16 minus x squared minus 4x, and I've multiplied that out. You can see the x times the minus x squared is giving me a minus x cubed, and then I have 16x and a minus 4x, which is giving me the 12x. And the other important information we want is what is the range on x here. Since we have this inequality up here for x and y, we see that x can't be bigger than 4 or less than minus 4, because then this x squared will be bigger than 16, and there's no way that this can be less than or equal to 16. And x can be plus or minus 4 by taking y to be 0. So the biggest and smallest x can be is minus 4 and 4. So that's going to be our range for x. So now we go ahead and see what happens when we take the derivative of g of x, because we want to take this derivative to find the critical points inside this region for our one variable problem now. So g prime of x will be a minus 3x squared plus 12, and we can check and see when that equals 0. We still have x between minus 4 and 4, but this equals 0. You take out a minus 3 or divide by minus 3. You're going to have x squared minus 4 equals 0, so x is going to be plus or minus 2. We need to check the endpoints, minus 4 and 4 here as well, so that's going to give me x is plus or minus 2 and x is plus or minus 4 to check. And we do want to make sure that this plus or minus 2 is inside this interval here where x is between -4 and 4, and they are, so we do want to consider them both, as well as plus or minus 4. To get the value of f at these points on the boundary, we just plug them into our function g of x, which is giving us those values. We can use this, or we can use this expression. Notice this expression is a little bit nicer for x equals plus or minus 4, because then you just have 16 minus 16 here. So this will be 0 at plus or minus 4, and then you have the minus 4x still to deal with. So when g is a minus 4, when we're looking at that, we're going to get, again, this is 0, and then we'll have plus 16, so that'll be plus 16. G of minus 2, we get 8 here, minus 24, which is giving us the minus 16. G of 2, we're going to have a minus 8 plus 24, and that's giving me a plus 16. And finally, g of 4, we get, this is 0 again, so this will be 0 minus 4 times 4, and so that gives me a minus 16. Okay? So these are our values of f, and on the boundary for this part, and inside for this part. So we have 5 different values that we need to look at. The 0 here, and the minus 16, and the 16, the minus 16, and the 16, and the problem is to determine which one's the largest and which one's the smallest. So we can see easily that the maximum value of our function is 16, and the minimum value is minus 16. But part of the problem was also to determine where they occur. So if I look at the 16 here, that's giving me my maximum, and that's 2 different places. X is minus 4 on the boundary, and x is 2 on the boundary. Okay, so we have this minus 4 to look at and this 2. Well, when x is minus 4, on the boundary we have x squared plus 4y squared equals 16. So when x is minus 4, we're going to get 16 plus 4y squared equals 16, and y is going to be 0. So y is 0 here, and that's the same thing will happen at 4 when we look at it, because we'll have 16 plus 4y squared equals 16, and y will have to be 0 on the boundary. For the plus and minus 2 that we have, when I plug that in, I get a 4 here. So bringing that over, this will become a 12, and I have 4y squared equal to 12. Y will be plus or minus the square root of 3 at minus 2 and 2. So to summarize, the global maximum is 16, and it occurs at minus 4, and then there y was 0, and it occurs at 2 for x, and there y was plus or minus the square root of 3. For the minimum, we're going to get minus 16, and that occurs when x is 4, and then y is 0, and it also occurs when x is minus 2, and y is plus or minus the square root of 3. So we've turned in the maximum and minimum values, and we determined where they occur inside our region.